Hello guys, this is Mohammed, your host in channel Humble Hustle. So today I have brought another exciting episode of Humble Hustle. In this episode, I'll discuss ideal app architecture, and then finally I'll discuss an architecture that I have implemented, which is known as use case architecture. So let's begin our discussion. Overview of the discussion that we will do today. Uh, so first we will discuss about the ideal architecture, and then we will discuss about modular architecture, and then we will compare these traits with MVVM and Redux that are most readily used architectures in the market, and then we will build ground for use case, and then finally we will discuss conclusion. So guys, as you know, that whenever we are building a software, our first priority is to design it in such a way that it is close to solid principles, which is separation of concern, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Now, first of all, our approach is to design classes in a manner that they only solve one problem, and the purpose of the class should be very clear. And secondly, our concern is reusability. That is, we do maximum reuse of already existing features, and then we look for centralization of initiation, which means typically factories. So whenever we follow factory pattern, that essentially centralizes our object creation, which benefits us in long term because we can control the initiation of the objects from one place. And then of course dependency injection helps us to test different modules of the application more accurately with higher coverage. And then we look for a mechanism to monitor the app's state, that is state mutations, and to know in which state the app is currently. This is typically useful while integration tests and unit tests, in which we have to test a specific state of the app. And then there is segregation of business logic, which is very essential in a way that we segregate the UI logic from business logic, and then we can also separate business logic and UI related logic into separate frameworks and follow a monolithic approach, which is very efficient, I would say, and saves a lot of time, as when we are talking about frameworks or SPMs, then they only have to compile once, and whole app do not have to compile, rather only the module in which we have changed. And then there's dependency inversion, which means we use protocol oriented programming. That is, we rely on abstractions rather than concretions, and in that manner we can have different concretions for the same abstraction. And then we look for a way where we can avoid side effects, that is the functions that exist typically in imperative programming, that are difficult to test. So an example of side effects is a function which do not give any output. For instance, it takes an input but do not return any output. For instance, in imperative programming we see functions like view did load, view will appear, view did appear, as such. So for that, I think declarative programming and frameworks like Swiftui are better. And apart from that, as I already mentioned, that we should rely on abstractions because that way we will design more flexible architecture, and we can have different concretions for the abstractions. So when I say abstraction, I'm referring to interfaces or protocols. So for instance, if we have an abstraction like data store, so we can implement it with realm or core data or user defaults. And the second point is loose coupling. So when I say loose coupling, it means that a typical module adheres to solving only one problem, and it does not tamper with other problems. And when I say high cohesion, I mean that uh, all the aspects in a module should contribute to solving only one problem. So these days we readily see MVVM architecture as being used in industry. So now I would like to discuss the MVVM architecture with you guys. So in MVVM architecture, what happens is that we have a view in which we have all the UI logic, and then we have a view model in which basically we have our transformation logic, and we are essentially placing all the observable objects and published properties in view model. Uh, so essentially view model is a layer between view and model in a pursuit so that we can only implement view logic in view module and all the transformation logic in view model. So that way we avoid the problem of fat views. But there is one issue, and that is we are putting more logic into view model. So it becomes a problem at some stage, probably a later stage in app evolution, which is not ideal. So and the other problem is that this architecture do not have any mechanism to monitor app state. So we have to resort to other architectures like Redux. So what happens in Redux is that essentially there is a state, one central state of the app, which keeps account of all the state transitions. State transitions are any change to the state of the object which involves different entities in the application, as well as application's state, uh, like which view we are monitoring at the moment, and interaction logic. So this has essentially three important aspects. One is the centralized Redux store, other area is reducer. So reducer is the area in which we use actions. Actions are essentially mechanisms to mutate the state. For instance, if I am working on a e-commerce application and the user purchases some product and places it into his cart, then there will be a separate action for placing the product in the cart, and for that action will go and make changes to the state inside a reducer, and then there will be a feedback cycle that will be followed. So Redux is more ideal for monitoring the state of the application, and the state transitions are more clear and easily testable. But at the same time, we have noticed that Redux requires a lot more work than MVVM. So this particular trait of state transition involves a lot of work as compared to MVVM. So this gives rise to a need for an architecture that is an intermediate architecture which possess the good traits of both the architecture, i.e. MVVM and Redux. So I have come up with this approach, which I call use case design pattern. Uh, so in this architecture, what happens is that we have a centralized app store, and in that app store we have state for routing, we have state for different information of the application. For instance, is loading, or which view is the user on at the moment, and that state trickles down to the main view. So main view is the view that is the main canvas that houses the other child views, and then there is a parent view that houses a content view, and the state information trickles down from main view to uh, parent view to the child view. And then there is a use case pattern that we use. So basically all the business logic is housed in this area, and the business logic also makes use of the repository, for instance, for loading different elements from the web service, or entities representing the business elements. So these use cases can be initiated from dependency container, and dependency container can also contain initialization logic for other subsystems. So let's have a deeper look into this. So I have a demo application that I have made to demonstrate this architecture to you. So what we have here is essentially we have an element of state store. So inside state store, basically all the information that is related to routing of the application, essentially dependency containers, which are the factories that are to be used, and other useful information about the application, as well as initialization of the use cases, as well as routing is contained. So as we see here, this is the initialization point where we are creating a state and passing it into the main view. So main view is the area where we use the state and we pass it on to the parent view. So in this case, you can see that there is a launching view which contains the state store information. So what it does is that it uses this state store to route to the next screen, that is the list screen for the meals. So as we can see, this is the parent view which embeds the content view for showing the listing of the meals. So what it does is that it takes the store and pass it on to the child view, which is the content view, which uses that store to populate the list. So what it does is that basically it calls a use case. So as I mentioned, we have a separate use case for every business aspect. In this case, the business aspect is start meals use case. So we start the use case, that is, we create a use case and we start it. So when we start it, essentially we are getting the meals from the web service that is being used. So what it does is that basically I have a logic written in combine which brings forth the elements from the web service and then passes them, and in case this web service becomes unavailable at some point, it will fall into the catch case, from where it will load data from the persistent store. So while it fetched the data, it also saved the data into the persistent store. So in case of offline mode, it will load the data from the persistent store. So other than that, I have a meal store that you can see is a protocol, and there is a concretion of this protocol, which is this concretion brings this concretion basically perform CRUD's operation for storing the data into the user defaults and then bring it forth. And other than that, there's an implementation of meals remote API. So this typical implementation relies on meals remote API fetchable protocol, as you can see and as we have discussed. So things to highlight are the dependency container. So this dependency container essentially is responsible for creating all the subsystems, like in this case you can see a meal store and a use case and a networking layer, that is this meal remote API. So we can use this architecture to design different use cases owing to our business logic. In this case, as we can see, there is a use case by the name meals use case. So what this typical use case does is that it fetches the entities that we require to populate the list content view. So we can have multiple use cases owing to the business logic, and the benefit of that will be there will be a separation of concern between business side and the UI side of the application. So people can work efficiently by using this architecture without stepping onto each other's toes. And at the same time, it is more testable as the approach we have used. For instance, let me demonstrate it to you. As you can see, inside this dependency container, we are making the meals remote API. So we can easily fake this by, let's say, passing a fake API. So this fake API has implementation that loads data from the JSON file that I have provided over here. So it will be handy for testing the UI part of the application. And that's all from my side for today. I will be sharing the link, that is the GitHub link for this application with this video, and you can come to me with any questions if you have. And other than that, I have also written a README for this application on GitHub, which you will find really helpful, I think. And other than that, please subscribe to my channel so that it will motivate me to create more such content, and let's do better coding together.